3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really is.
Level.
It really is.
Level.
And bam, there's the radius of the Earth.
How does water manage to get itself into that negative pressure state?
What are you talking about, Bev?
Hydrostatic.
Yeah, hydrostatic equilibrium refers to, I guess, if you want to, with water,
Yeah.
it's the pressure going upward, the pressure created from the weight going downward, and then equalizing.
Yeah, and
So
it establishes
all it's going to do is it's going to make a level
equilibrium.
Yeah, it's just going to keep things level. So if you've had it going over a long distance, it just keeps the water at the same level.
Yeah, even altitude.
Yeah, so I don't see what the problem with that is.
Well, and the water establishing an equilibrium of even altitude at a zero pressure state.
True.
Yeah, and when they measure like an increase in pressure in the hydrostatics, it's the column of the water, right, isn't it? Measured as a vertical height away from that zero pressure equilibrium point line, let's say, or plane, horizontal plane, because that's the way the water does, isn't it? It establishes a horizontal plane of reference. So that zero pressure state of the hydrostatic equilibrium might be a horizontal plane, right?
Now, what are you trying to say, Bev?
Brandon,
You're talking shit.
Yeah. There's no water doesn't hum.
Yeah, in a minute. Kosho, what's going on, man? What do you think about the conversation at hand? Do you agree with that little discussion that we just had about establishing horizontals, etc.?
No, I can't say I do. I did post a picture, though, and it will give you an idea of what I think the confusion might be.
Okay. Confusion? Who's confusion?
My picture, I have 2 red lines. Those red lines are local horizontals. Yeah, they're local horizontals made from the 4th and the 6th post. Those are the red lines.
But they're
the blue lines
you say they're
that
horizontal.
Yeah, the blue lines that are standing straight up vertical.
They're not horizontal.
That would make the water level at each of those different positions.
There isn't one
line.
Oh well, there is.
Right,
See that grid in the background.
Let him get it out of his mouth, please. I want to hear what he has to say. Right. Go ahead.
I've drawn a light blue line that would be created if you were to look at the 2nd post to the 6th post and make a straight line, but I wouldn't call that horizontal by any measure.
See that grid in the background?
No, on this ball Earth, it would not be level. It would not be a horizontal. I wouldn't consider that a horizontal either.
Right. You cannot see how ludicrous that is.
Is that an XY grid in the background?
I want to know where I would see those blue lines.
Those blue lines would be made if you were to make a water level with different posts in it. It would make something like that.
Is that an XY grid in the background?
So if you had posts sticking up like that, I would see them doing that.
Do you think we don't understand this, Kosho? That this is what you believe?
Kosho.
I mean,
Real world demonstration.
Kosho, do you think this is not what we don't understand this?
Well, I think Bev doesn't understand it, but you just asked me. That's the only reason I presented it.
No, that's what I'm asking. What gives you the impression that we don't understand that you believe this is how it works?
I've talked to Bev before, and so I know that he doesn't understand it. With you others, I can't make any assumptions.
What we were just talking about, or what Bev says, leads you to believe that he doesn't understand how this works? Bev, do you know this is how this works on a ball, or do you disagree with it?
I completely understand the inner workings of imaginometry. In fact, I think I understand it much better than Kosho does. Kosho is unwilling to think about this. Because it's just a smear campaign, right,
because he didn't understand it.
Just a smear campaign coming that Bev doesn't understand things. I mean, you've heard it from Rumpus and all of that.
Well, that's what I'm trying to get him to say. What he doesn't think he thinks you don't understand, because you've showed this. We understand that this is what you believe. I don't know what it is you think.
I understand that you understand this. When I made this weeks ago, it was in a conversation with Bev, But I made it because he didn't understand it. I showed it to him. He still didn't get it because afterwards he had drawn the horizontals from each of those posts would be horizontal to the actual picture.
Did I ask you about the grid in the background? Is that an XY grid? Because I would say that was like verticals and horizontals.
You see what I mean?
Those lines on that grid in the background. Because them red lines and blue lines and all of that, they're not vertical or horizontal. There might be one. One of them might be actually vertical. Have you tried hanging a plumb bob up or putting a level close to him? See, just to check.
Do you see what I mean now, Brandon?
Well, I don't know what I don't exactly understand the question, but I'm gonna let Bev keep going.
No, I'm saying when I say he doesn't understand it, he's saying that the horizontals are horizontal to the graph in the picture.
No, Kosho, you're the one that doesn't understand what Bev is doing.
Then why did Brennan just say it? He said that he understands that that this is the way that we see it, which that's perfectly fine. That is what you guys should think that we say the world is, just with the way I said. Bev is again saying that horizontal is not that on the graph. It's horizontal is the lines that are matching the lines in the background, the X grid in the background, which is not. That's not.
I do agree with him on that, but this is an on the ball. Yeah, okay, I get what you're trying to say, and I think Bev does too. I don't think he doesn't understand. I think he's just asking you, pointing something out about those red lines that neither of them are horizontal or vertical. But
they are locally horizontal. Yeah. Those are locally horizontal on that picture. If that was the Earth and the Earth were round, those would be two locally horizontal lines.
Right. Well, can I point out, right, that I call it a fortunate. I mean, some people may say unfortunate. I call it like my mind wipe helped me in the fact that I don't have a model. Right. I only can go with what fits reality. Right. And to me, that's fucking ridiculous. I can only go with what a horizontal is and what a vertical is. To me, in reality, right? I can't go bending it and I can't have horizontals intersecting each other. Because I can't imagine how on earth you would ever measure that. How do you measure where a horizontal intersects with a horizontal, the angular change where horizontals meet each other? How could you possibly ever imagine you could measure that, Kosho?
Well, George had done it.
George has done it.
The Bedford level test.
They've measured the angular divergence of a horizontal with a horizontal.
No, they measured the horizontal line going through from one position is not going to be the same one that is going to be at the positions it's pointed at. And there's another.
How did they? Why, Kosho? Please explain that.
You've seen George's test, man.
You muffled your way through that.
And you've seen George's test.
Please explain.
So, I'll go over the Bedford level test, where they simply looked at the canal that you plan to go to, and they took one.
The canal that I plan to go to.
Yes, you said you were going to go there for your test. Anyway, he's going to go there. Bedford? He went there.
No, yeah, I've already been to Bedford, and I'm not going to Bedford.
He went there, and he looked down.
That's where Rumpus is going.
That's fine, Bev. That's fine. Don't ask me to explain something, then talk over it.
Well, you're explaining it all wrong. Don't tell me that's where I'm going. If I'm not actually going there.
Yeah, you said you were going to do your test right beside the Bedford
No,
canal.
I didn't.
You said.
No.
You did say this, yes. You can say that you're not doing that anymore, but that is what you said. But regardless, the Bedford level test back in the 1800s, he was looking down on the sites. He looked down at, when he went done correctly, they looked at 3 posts
prototype
down the canal, 6 miles down, I think it was. And they were all the same level, so they're the same height above the water towards one another. But the straight line made from the position he was standing to the first and the third one, they were lower than the one in the middle.
Oh, so the one in the middle was up?
It was
higher. Higher as in the up direction?
Higher as in his straight line that he created from his reference point.
Yeah.
It was higher than that line, than that horizontal.
Is that
that's the Bislin
hump? The Bislin hump. Yeah. You know, what do you know about water and hydrostatic pressure, Kosho?
I know that you guys use that term.
Do you imagine that water can support itself in a central position?
Yeah, why not?
So like, imagine like we had,
Wow.
if we had, say 16 water levels, right? Now, would the hump be in the middle of each of them?
Talking about?
Well,
hump?
This hump, the one that you've just seen, that you said that the Bedford level fella seen.
You can see in the picture I've drawn.
Yeah,
I've drawn a picture with 7 different water
where
levels.
water supports itself in the
now.
center. Yeah. Okay.
Yeah.
Right. Yeah.
I've drawn a picture with 7 water levels.
Yeah.
And there's a line from the 2nd to the 6th one, and you can see that there's, or maybe it's the 2nd and the 5th.
Yeah.
But there's no, it's 6th. Either way, there's 3 in the middle that are all higher than it. So depending on which 2 you were looking at, the ones between them would be higher. Sure.
Right. So that the ones there, the water is well, see, the way I think of that zero pressure state is if you go down in the downwards direction, then you increase pressure, and if you go up with the water from that static what do you call it, hydrostatic equilibrium point of zero pressure, right? If you take the water in up from that zero pressure state, it goes into a negative pressure state, right? How does it get into? How does water manage to get itself into that negative pressure state?
What are you talking about, Bev?
Hydrostatic.
Yeah, hydrostatic equilibrium refers to, I guess, if you want to, with water, it's the pressure going upward, the pressure created from the weight going downward, and them equalizing.
Yeah, and
so
it establishes
there's nothing. All it's going to do is it's going to make a level
equilibrium.
Yeah, it's just going to keep things level. So if you've had it going over a long distance, it just keeps the water at the same level.
Yeah, even altitude.
Yeah, so I don't see what the problem with that is.
Well, and the water establishing an equilibrium of even altitude at a zero pressure state.
Sure.
Yeah, and when they measure like an increase in pressure in the hydrostatics, it's the column of the water, right, isn't it? Measured as a vertical height away from that zero pressure equilibrium point line, let's say, or plane, horizontal plane, because that's the way the water does, isn't it? It establishes a horizontal plane of reference. So that zero pressure state of the hydrostatic equilibrium might be a horizontal plane, right?
No, what are you trying to say, Bev?
Brandon,
you're talking shit.
Yeah. There's no water doesn't hump.
Yeah, in a minute.
That's what I think. That's what we're trying to say.
The Bedford level test shows exactly what my picture shows.
Water level establishes a horizontal plane of reference. Level is a straight line
level
on a
test,
horizontal plane.
The challenge the guy did he won the bed, was because he did exactly what I showed. That there's in the middle targets were higher than the 2 end targets.
Yeah, the problem with that also was he didn't cite the targets correctly. He cited to the middle, which added to a hump in the middle with the curvature of the lens and the atmospherics. But if you cite to the end, it's a straight line. What's his name went over it in some of the old 1800s publications, Earth Not a Globe or whatever, the old 1800s pamphlets talking about it. Went over.
What are you talking about? Somebody else? What somebody else said?
The Bedford level bet with that other guy Wallace. He used some camera tricks basically to make it look like
they did all sorts of bullshit for all sorts of stupid reasons. Flat Earth Society type shit, right? All of it, the whole thing, a load of bullshit.
And the thing is, Kosho, the
water doesn't
idea
hump.
Of equilibrium. Well, the idea of equilibrium
doesn't drop, doesn't rise, and it doesn't hump.
Obviously,
stays
They tell
horizontal.
us the Earth drops away, so why would we have a fucking hump?
Well, if you want to see a hump, go look at a camel.
Well, the thing is
that a physical drop or a visual one?
Physical.
The idea of equilibrium period philosophically, Kosho.
It's not philosophically.
It's easy to measure physically.
It's actually, in reality, that's what we were talking about. Not philosophically or anything. We were talking about in reality.
Yes, Kosho. The problem is to have equilibrium, it has to equalize with something else. Equalizing with what over a gravity ball?
Zero pressure.
There is no theoretical point to equalize with.
Establishes a level.
Why do you have to talk through everyone? Let him finish, man.
I'm just going to finish really quickly. There's nothing to equalize with over a ball. You can only equalize with another flat level plane.
That's fine, Lemon, but you know that it's in reference to the center of gravity. That's where it's that's what's going to set the level. But
that's hypothetical. There's no analog in reality to say this is what we're equalizing with. That's highly philosophical without any analog in reality, as far as we can tell.
Sea level.
Yeah, sea level is one example. The Bedford level, as I just went over, is another example. And anybody, yeah, and planes do this.
We got somebody calling out the words. What do we need?
It's my main man.
Circle. Oblate.
The last thing I was just going to say is another example is planes in the sky. Because I know pilots who talk about, seeing on the radar that there's a plane that is well over his head, 100 feet above him, and in the distance he sees that it's below his level, and that's because it's far enough ahead of him that it's below his. It's below him in like I said in the sense of being level, his horizontal. But it's technically above him as far as elevation goes.
Couldn't be just an optical phenomenon, no?
Something is level, that's what it's level in reference to.
Do you know why they don't reference the center of Earth?
Because it would be weird and confusing if they... Oh, okay.
That's why.
Because they've never measured a radius, they don't know where the centre is. Don't know how to describe a circle.
Measuring the radius is quite simple. If you measure a radius on a flat plane,
hold on. No, we're not. We're not talking.
More difficult.
We're not talking. We're not talking about calculating the radius. We're talking about physically measuring, not calculating. Okay.
Okay. How do you propose to do that?
I don't. It's not my fucking claim, you mong.
Assume that. Let's just say for 1 minute.
Well, it was Kosho, wasn't it?
The Earth is round. How would you measure?
Why is Kosho tapped out? Kosho was the one that was asked to justify his. It's easy to measure.
Wait, what was I asked? I wasn't asked anything.
No, you said it's easy to measure the radius.
It's quite simple,
yeah.
Sure. There's plenty of different.
And then he asked you were asked. Could you please demonstrate it? And then Andy decided.
No, yeah, I thought he just said no. That's not. I thought he said it's not calculate. Yeah. I'm talking about calculating. I'm talking about measuring.
Yeah.
So there's two dudes back in the day who've done it.
How do you measure?
Yeah.
Go on.
Yeah, well, you can use Al-Biruni's method or Aristophanes' method.
The radius.
Or some modern
Fuck me. Go away.
Yeah.
Radius.
The fact that you just.
That's right.
The fact that you just referenced Al-Biruni shows you have no standing to make any claims right now. Absolutely insane that you're making.
It says you.
No, you don't. No, you don't.
Even a flat earther said that it was
I don't give a shit.
Gave you the radius
flat
of the Earth.
Earther means nothing.
What's his name? What's that guy? J. Tolan.
Flat earther means nothing.
A flat earther said it would give you the radius of Earth. Did you really just say that? That guy, if they said that.
Yeah, he said. What he said was, he can see how we got the radius of the Earth by using that.
How did you measure the radius of the Earth? Kosho, please.
Keep him on track, Beth.
Yeah, you start by measuring your altitude, and then you.
Which is which is a vertical.
And you take those two numbers,
height
and it gives you the radius
difference from sea level, right? The altitude that you start off with.
That's not what I said. The problem is if you try to use words to say what I said, you're going to say something completely different. I didn't say anything about that.
But you skimmed over a load of stuff. Right, okay.
So the altitude of whatever you are from the ground.
Yes.
Doesn't matter where you are on the Earth.
Okay, which is vertical height above sea level, right?
No, I'm not talking about vertical height above sea level. I'm not talking about that.
You said
I'm
elevation,
saying, so stop
right?
talking, that way people can know what I'm saying.
Okay, well, let's start off again then.
If you're in a building that's 100 feet high,
yeah,
you can use 100 feet.
Okay, so just the building then that you're in.
Any height. Any
okay.
height that you
All right, okay. So we get a height above something else, right? Yeah, okay.
You go ahead, Bev.
Well, I'm just trying to establish how we do this to measure the radius.
Don't try to establish anything. Let me finish what I'm saying, and then it'll go much easier.
Well, I'm trying to keep with you. I'm going to be drawing it on the board, right?
Sounded like you were done there, Kosho.
Get the whiteboard out, Bev.
And then you jumped on him.
Should I? Do you want us to get Should we get the whiteboard on, and you can draw, you can work us through how you actually do, how you measure the curvature?
The whole time
to do that.
I can say it in less than 10 seconds, or you can talk over me. It's whatever you want.
Oh, we can't use video. Can't put the video chat on.
Kosho, do the whiteboard with him.
Summon the Mullen.
Yeah, it's simple. It's simple. You just take the height of whatever you are.
Right, okay.
And the angular drop of the horizon from that height.
Okay.
Bada bing, bada boom.
All right. Yeah. What are you measuring to?
I'm drawing it. How do you measure the horizon? How do you measure?
And how the fuck does that tell you the radius?
Okay.
So
we start off at one point. I can't put my video camera on. There's too many people in here. But imagine I'm drawing a triangle, right, Kosho? And I'm one side
There's
of
a picture there for you, Bev.
Is labelled A and B, and that B is the height. So A is the bottom, where we're starting from.
I got a picture for you.
And
there's no need to ask. There's a picture in there for you.
Where's the angle that we want?
The picture is in the chat for you, Bev.
Yeah, I work much better when I can do it in my head, myself. So I've got...
Oh, yeah. Well, then use the picture and do it in your head.
I've got a height B. Like, that's a height above somewhere. You said it didn't really matter where. So let's say...
They've assumed the radius, Bev.
Let's say it's a B.
Look at the image. They've assumed the radius.
I know. I can almost imagine that somewhere on there he would have to draw a big wazzing circle somewhere. But we're not bothered about that. We're just at the top of a 100-foot building and some sort of an angle. Kosho?
It's in the chat, man.
Where do we get this angle from?
It's in the chat.
Where do we get the angle from, Kosho? Because I'm at the top of a 100-foot building and I need an angle. How do I measure this angle, please?
You know that. So don't ask me any more questions, please. The picture's in the chat.
I'm asking you how you easily measure
I just told you
the radius.
I just told you how, and that's the last thing I'm going to give you.
Easily, you said. You used the word easily. Can you not easily explain how to do this easy job of measuring?
I tried, Bev, but you talked over everything I said. So I posted a picture, and you can use that instead.
Hello, Mr. Bufffinger.
Can't see it. I'm at my whiteboard.
It's too bad, man.
So is that it? We've so far we've got a line, and it goes A to B. Is that it? Is that it?
So far, you've got a line. Everybody else can listen to what I said and then use that picture. You talked over what I said at the end, so unfortunately, if they didn't hear that, they could still use the picture because it's got all the math.
Okay, so you can't do it then. Okay, no, that's okay. I've left it.
It's got the assumed radius in, Bev. It's a load of bollocks.
No, I was waiting for Kosho to explain it. He just said, "Look at."
You weren't waiting, Bev. You were talking. You weren't waiting. Waiting is when you close your mouth.
Video's on there,
and then don't say anything when I'm talking. That would be waiting.
See the video? Can you see the camera now? Look, you can. You can see it, can't you? Yeah.
The picture's in the chat, man.
A, B, and this was the height. It was 100 feet. You said, didn't you? There you go.
Yeah, it's in the chat, Bev. Just copy what's in the chat.
We're 100 feet above something. And I was
waiting
to see where's the angle come from?
There's no need to wait, Bev. Just copy what's in the chat.
How do you measure the horizon?
Can you just explain it for us, please?
No, yeah, but that's going to have to include you not talking. And so we'll see if that happens. As I said, you take any height. Say 100 feet, doesn't matter. You take that height, and then you measure the angular drop of the horizon from that height. And then you do the equation at the bottom of the board there that shows that. The rest of the math is just a proof for why that equation works. But when you use that equation at the bottom, you get what would be the radius of the Earth.
The angle there. Right, that's the angle we've measured.
Could be any angle.
Yeah? Kosho?
I'm not sure what kind of confirmations you need based off what I said, but all the information's in that picture, Bev.
You've gone up here, 100 feet up. You've gone 100 feet up, and we've measured an angle. Yeah? What do we do with this angle now? What was it? I missed it.
Plug into that equation at the bottom there. I've said this already, Bev.
What equation?
I really hope you don't ask me to say it again.
What equation?
How far's the horizon for a fucking start off?
We've got 100 feet here and then some sort of an angle.
Yeah, to the horizon, he said, Bev. How far is
just
the
an angle,
horizon?
though, isn't it?
He doesn't know. He doesn't know.
Of course you don't, because you don't know whether it's
okay, first of all, the distance to the horizon is irrelevant in this measurement.
What do you
distance
mean?
to the horizon is not part of this measurement, so it doesn't matter what it is.
We just need this irrelevant height.
You've just sent Bev up a fucking height.
The height is relevant. The height is relevant, and the angular drop of the
100
horizon is relevant. Those are the only two pieces of information that are relevant.
Kosho.
Okay.
Kosho. No, wait a minute. You said we were up a 100-foot building. That was the only thing that was relevant, right? Not the height that the building was, elevation-wise, just the 100-foot building.
Two things. The height and the angular drop of the horizon.
Angle. Yeah.
Once you have those, you plug them into the equation at the bottom of that thing that I posted. That B-ball posted again.
How far's the horizon?
That's it.
Roll to the angle.
No, wait a minute. Right. No, come on. Come on, Kosho. Look, we've got a height and an angle. Right?
That's right. That's all you need.
And it's all I need to what?
Measure the radius of the Earth.
Well, I can go up a building and measure an angle, and that will give me the radius of the Earth.
That's right. That's how easy it is.
Let's show you workings out on that.
Go on, give us the equation then. Let's see the equation that we use.
I've given it to you twice now. I told you I wasn't doing it again. You can scroll through the chat. B-Baller posted it again most recently.
So we know we're 100 foot up, and let's say we've got an angle of what, Bev? 30 degrees?
I don't know. Like, is this imaginometry?
Degrees then?
Yeah.
What do you do with that to get your ludicrous fucking assumption that we live on a ball?
It's not some kind of proof of the globe. It's a measurement of the radius of the globe.
No, because we've got, like, look, in reality, this is what you've got. There you go. Can you see that?
Looking.
There's this. You couldn't put a distance on that, right? So that is literally you've got a height there from that bit, and you've got no length on this, so you've got one distance and one angle. Off you go, big lad.
The things that are relevant.
Off you go.
That's right.
Bam.
So we're working with 100 feet elevation and 30 degrees.
Yeah, let's say that.
So
off you go.
Let's see how you work that out to the fucking radius of the Earth.
Go on.
Well, you have to have those measurements. You'll know generally from a plane.
We've got 100 feet and say 33 degrees.
Never just talks over everybody, man. It's like you think it's always your time to talk. I'm literally saying he said a height in degrees. A height of a plane usually will have a little bit less than 3 degrees.
Oh. What? A plane? No, we were on a building. Like, where have you got a plane from?
He used a really poor example.
No, that was your example, Kosho. Really easy.
Yeah,
really easy. Off you go.
You just heard me say my example. Yeah, I'm not on 100. I'm not 100 on a 100-foot building.
100 foot
I'm measuring the
and 33 degrees.
Oh no.
Oh, 66 degrees.
We could have let's say the building's 133 feet. And then we could have 33 degrees, couldn't we?
Or we could have 3.33 degrees.
We could.
666 degrees.
Or we could
or
have
6.66 degrees.
What do you reckon, Kosho? Go on. Show us your little snazzy magic trick and conjure us up a radius of the Earth, please? And bam! There's the radius of the Earth.
You can use it or not.
You'd only be the first person to find a ore.
Yeah, I mean, like, Jesse did it with 3 coplanar points, didn't he? And now what you're going to do is you're going to do it with a distance and an angle. And bam! There's the radius of the Earth. Come on, Kosho. What do you reckon?
It wouldn't come to 39.59.
It might be. We can estimate it, Brian. I think that might be a good estimate.
I'll bet it does.
How'd you get there, Kosho?
Show us your workings, Kosho. On the corner of your page, show us the workings.
Right, what it is, it's 100. You've got 100 feet and an angle of 33 degrees, and then it's got to equal 3959 or something like that. Yes.
Use real data from the real world.
Yeah,
Made up the data from
It says how easy it is, but can't show it.
That's it.
It's fucking ludicrous.
Plug in numbers to a formula.
Yeah, 100 feet and then an angle.
You're halfway there. Then you're halfway there. Now you need data. You need data. So you need to
that's
get an
the data that we've got. We've got 100 feet and an angle.
You need to get a real angle from that height.
Yeah. What was the angle that you got when you did it?
I used data that I found elsewhere, but this data is from. Here, hold on.
It's easy.
This data is from.
Just
this
imagine.
data is from.
Imagine.
Yeah, this data is from England from the 1700s.
Okay. Oh wow, some old data. Is that be an old angle?
You can search for
some old school angles.
Like to use.
Back from the 1700s.
Kosho, don't you see how fucking ludicrous this is? What you're saying?
What's the angle then?
Yeah, it's so ludicrous that only the crazy people online think that it's not true. That's how crazy it is.
That's how easy it is.
Fucking mental.
Yeah.
If you cross the building with an airplane with your angle, why'd fly down? Would it not hit the earth? I'd fly up the other side then. Right.
No, we want him to show how easy it is.
Come on, just show us, Kosho. You like?
Right, give me some data then. I gave you some data.
No, you
plug those numbers into the formula and see what you get.
What formula? Show us.
I've given you the formula. This is what I'm saying. What's the
Where's
point
the
of showing
formula?
anything to you when I showed
Where
you?
is
You
the
claim you
formula?
haven't seen it.
You said it was easy.
Where
It's
is
been
it?
given to you, Bev.
Where
you
is
figure
it?
That, figure that
Where
out.
is
You can't
it?
see it, can he? You can't see the chat.
Figure that out, Bev. It's in the chat.
Oh, sure. You getting paid for doing this bullshit or what?
Exactly. I'm not getting paid, so I'm not going to keep presenting to you guys the same things over and over again. If it's been posted in the chat, everything in there is for everything for you is in there.
Where?
That's all you're gonna need.
Where, Kosho?
It doesn't make sense what you're doing.
Where, Kosho? Come on.
We're 333 feet up and we've got an angle of 3.33 degrees.
Yeah.
Right. Now,
you wouldn't have an angle that big if you were that height.
We need numbers.
How do you know what angle would you get?
I know the horizon.
What angle do we need to have to give us 3959 miles? Come on. How do we get?
It depends on what altitude you are.
Okay, well, what altitude do we need to have to? What altitude and what angle do we need to plug into this thing in order to get 3959?
This data table, the data table on the right there, has different altitudes and different angles.
We need you to show.
Can you see this, Kosho?
Cross the angle.
No, I doubt if he's got it.
I've given you what I've given you. I'm not speaking to you more, Bev.
Right. Okay. Right. Well, like, can you? I'll for everybody else, just as a little quickie.
It's in the chat. In the chat is both the formula.
I know.
We're not.
I don't give a shit about you. You said you're done, Kosho. You said you're done.
No, you don't. So then don't ask me to give you something. If I give it to you, and then you just ask me some more. It's in the chat.
Are you done?
Want to figure it out? Plug it in.
Okay. This is a straight line and an angle. The best you could do with this in order to predict anything would be to predict, first of all, a triangle. So if, let's say, Kosho ever managed to be able to do anything to finish off the rest of this triangle, but he can't. But if he could, then he would have a triangle. Now, a triangle has 3 straight lines and 3 angles that add up to 180 degrees. I mean, all triangles have that. They're all the same. Now, what Kosho seems to be able to predict is with the height of a building, and providing he could make a triangle here, he would then have a triangle with known distances. But I mean, just having a triangle, what doesn't help you make an imaginary ball underneath?
Yeah, fun fact, especially for people who claim to know geometry, trigonometry fairly well.
Okay.
I'll go ahead and make you aware.
Yeah.
That to find the sides and the angles of a triangle,
I'm ready.
You only need 3 out of the 6 pieces of information to get all the other 3 pieces of information.
We've got
if you have 2 angles and a side.
We have.
You can actually figure out the rest.
We've only got one side and 1 angle though, so.
Yeah, we only have 1 angle.
No, you have 2 angles.
Where?
One of the angles from the horizon to the center, as in the picture there.
What?
Because you can see it in the picture that I posted and showed to you.
No, this is a drawing here. Tell me where I should.
It's a 90-degree right angle.
Where? Where?
I'll let you search until you find it, man. In the picture I posted.
I'm just doing it here, pointing. Look. Can you not see me? Wait, where is the right angle?
I'm looking at your screen now. And the picture I posted, there's a right angle, man.
Trigonometry uses 3 straight lines. Not 2 straight lines and a curved line. That's not trigonometry.
There's no curved lines in the triangle that's not that I'm talking about.
A curved line of Earth.
Where?
Curved lines. There's no curved lines.
No, I know. We've only got 100 feet there in
line.
that 1 angle. That's all we've got.
Does Earth not curve then?
I'm sick of people saying it's easy.
Yeah.
There's a line going straight down.
If
there's a line going
this
to the
isn't
horizon,
exactly
there's
like
a
what
line
we've
going
had to
straight down
deal
the
with for the
horizon.
past
There's only 3 lines.
week
All
or
3
what?
straight lines.
3 straight lines of a triangle. Yeah, I mean that's what we know that 180
3 straight lines
degrees.
of a triangle.
Right.
Yeah, and you have 2 of the sides. You have a portion of one of the other sides.
I know.
What you're looking for is the rest of that line and the other line that you don't have.
Yeah,
and all you have to do is plug the numbers into the equation that I've given you.
It's all there. Stuff we don't have.
Yeah, and the bottom of the page that I've given you, it has the equation to figure out what that rest of that line is.
On the picture.
Bev, what he's saying is you've got to draw the Earth in at the base of your vertical. You've got to draw the Earth in at the base of your vertical.
I'm waiting for him to say that.
But what he's saying is...
There's no point waiting for me to say. I'm giving you what you need, man.
Bev, can you do me a quick
saying it
favor
isn't
and just draw
curved,
me a
it's flat.
triangle on your... Can you just do me a quick favor, Bev, and draw me a triangle on your whiteboard for Kosho?
I'm not looking at his whiteboard.
So deluded, man.
It amazes me that adults can look at that and still be confused on what's going on and what's where.
I see.
It's like everything you need is in that one picture I posted. Not only does it have the formula at the bottom, but it has the proofs to how that formula is obtained.
You have just said that Earth's surface to the horizon is not curved.
I did not say that. I didn't say that one time. I said the 3 lines on this triangle are all straight lines. If you notice, the Earth's surface is not one of those lines.
What's the bottom line then?
Do you see where the triangle is on that paper? Yes. On that page I posted?
Yes.
Okay, tell me which part is the Earth's surface?
Well, presumably, if Bev's on a 100-foot tall building, it would be at the base of that building, would it not?
No. No, that's not the triangle that this is talking about.
So what line?
It's talking about the triangle that's going from line of sight to the horizon, and then your position to the center, and then the position of the horizon to the center. Those are the 3 straight lines that it's talking about.
So not a line from the base of the building to the horizon, no?
No.
So where's your 3rd line coming then?
Do you see where they are on the page?
Yeah. See where they are here.
Like they're on the page.
What page?
Is the bottom line a vertical? I just don't.
Yeah, I'll name the 3 lines. There's A to C, okay. And there's A
C?
to O, and then there's C to O. Those are the 3 lines, Brian.
Kosho, I'm on my board here now. I've got A and B. Where's the rest of these lines and these points? Come on, walk us through them.
Refer to the page, Bev.
Work
I'm not
us
helping you
through.
out anymore.
Wait. Come on, Kosho. Surely you can describe this model and show us where we are.
But you're trying your hardest not to understand it. The page is in the chat. If you were that determined to know what's going on here, you would just simply look at it.
Oh, look,
So I'm not dealing with you right now.
Put the Veach. Put the Veach up here. He's gone up his 100-foot building.
Put the C on the other line.
On what other line?
Connect A to C.
Which other line?
Is that what you're talking about, Kosho?
Which line?
In reference to what he's, I mean, I don't know what he's
Where's
trying.
A?
I don't know why he doesn't just look at the picture.
A's at the base of the building.
I think he's talking parallel with A.
Yeah.
Another line.
Another line?
Yeah.
From A.
Why are y'all playing this game? You just simply look at the screen. It's on the screen.
Oh my god.
He's got his camera on. He can't see the fucking chat. How thick are you?
There you go, like that. How's that?
Move the camera.
Then you wouldn't have his camera on, would he?
Okay.
Kosho.
Move that page and open up the Discord.
Explain it rather than making him have to fuck around.
Yeah.
Come on.
This building. We've gone up the building.
Move that down to point A.
Yeah, shut the fuck
I can't get it down any further than that.
Oh, Lord. Well, move point A up a bit then. Scrub that out of the bottom.
But what is this, though? I mean, like, what is this baseline we're doing here, Kosho? What's this meant to be?
What is that baseline, Kosho?
Yeah. I mean, because all we had was a building. We've gone up a building.
Draw the half of a circle.
What?
Trace the you have on your board.
A circle?
The top half of a circle.
You want me to draw a circle?
Draw the top half of a circle. This is one time only, dude.
Where's the circle come from?
Draw the top half of a
the
circle.
Building.
And draw a building on top of it.
You want me to draw a building on a circle?
The top half of a circle and a building on top of it. This is exactly why it's easier for you to just look at the fucking picture.
Do you build buildings on circles? Would you not want to make a level foundation first?
Oh my.
Do we build? We don't. We have level foundations for buildings. I'm not putting a building on a circle. I don't. We don't do that. That wouldn't last.
The baseline he's talking about, mate, is the curvature of the Earth. So he's now built a triangle with one bent side.
Right. Oh, so would they? You're assuming this is
the triangle has no bent sides. The triangle are all straight lines.
Okay. So all triangles would have 180 degrees, wouldn't they, Kosho?
This triangle has 180 degrees.
Yeah, all triangles would have 180 degrees, wouldn't they, Kosho?
This triangle does.
Yeah, all triangles would, wouldn't they?
Would they if one line's bent?
I don't think that would be a triangle. That wouldn't be a triangle then, would it, Brian?
Kosho, in your image...
Brian, lines, you can think of the lines as A and O, C and O, and A and C. If you look at those three lines, none of them are bent, Brian.
Okay.
Oh, where's O? Oh, sorry. Where are we putting O?
Yeah, what's this?
It's on the picture, Brian.
Beth, you got to draw.
I think you have your camera on too, right? You can see in the chat.
What on?
How do you work that out then? Where is O?
Is A to B this A to B? Is that what I've got? I've got B and A the wrong way around.
Yeah, but you have to extend that, Bev. You have to extend that.
No, but I mean this is all we've got, isn't it? A and B, right? Would that be right? The height, Kosho, and then we've got an angle, which we have got the angle. A, you called that A, angle A.
Hey, Kosho, you just proved to us we can't measure O.
Okay.
Yeah, that's what the formula's for. Okay, if you see the picture, those who can see it and decide to look at it.
Wait a minute.
Please don't talk. Please don't talk, Bev. I'm trying to explain to people who are still trying to figure this out. If you see it in the picture, there's different numbers and letters, and R is the number you're trying to figure out. So you're right. You don't know R. You don't know where it is and how far it is to O. But you do know the height of the observer. That's why the H is right there.
Like that.
You also know the angular drop of the horizontal to the horizon, which is what the angle A is. If you go to the bottom of that black page, there's a formula that says R equals H, which is the height, times the cosine of that angle, over 1 minus cosine of that angle. And when you plug this number in with data that you take from this measurement, you get the radius of the Earth.
Not the cosine of the side then this time. We're doing the cosine of the
angle at C, which I don't understand how you've got that angle.
Okay. So from the top of your observation, you would be you'd measure a horizontal, like a horizontal line, and you'd measure the dip of the horizon. So the angular dip
like that,
of where the horizon is in reference to that horizontal.
Like that. Hey, there. Ooh.
So how far away is the horizon?
You've only got the angle there, though.
It's not relevant in figuring this one out.
Not relevant.
Yeah.
You by figuring out the radius, though, you can use another equation to figure
Just
out what
need
that,
this angle
what
here,
that
right?
line is, A and C, but it's not necessary.
Just need this height here, and then this angle from the horizontal down towards the horizon, right? No, you don't need a zenith angle, like you don't need that. No, just the angle from the horizontal in the downward direction, right?
Yeah, how do you figure that one out?
That's right, Kosho, isn't it?
All the proof
You just
for
need
the
this
formula
height and
is
that
there in the chat as
angle
well.
there.
It shows you how it's derived.
Down from horizontal. And then there's something else goes on down here, but I mean that's what you're gonna get out of it. I mean that's the answer, is this bit here. So this is what you've got, and then from this you do all of this. But how do you get this? Because that's what you're doing. It's easy, isn't it?
I think he's right, Bev. That's how Ronaldo scores goals. He bends, he kicks the ball and he curls them into the upper.
Yeah. Kosho, come on, man. This is dead easy, you said.
So we bend it
It's
like
really
Kosho,
easy,
do
yeah.
we?
For those with minds and wills to understand, it's fairly easy.
Yeah, go on then.
Oh, we understand.
I've given it to you, Bev.
Yeah.
Bev, it's only going to work if you draw a circle on the board.
Yeah, but that circle's what we're trying to find. Like, we describe the circle by a centre point and a distance away from that centre point, known as a radius. But Kosho said that's what this will find. So I can't draw the circle without knowing the radius. So the radius is what you're going to find for us.
Imagine that you're not drawing it to scale.
It's a fallacy.
Imagine that you're not drawing it to scale. And it doesn't matter what size circle you make.
No, you gonna. I can't. No, I can't. Kosho, I cannot describe a circle without knowing the centre point and the distance from that centre point. That's what a circle. That's how you describe a circle.
I'm sorry to hear that.
Okay,
so Kosho, where do we get the value of C in your equation? I'm assuming the C stands for...
The value of C, that angle is 90 degrees because that's the angle that you're gonna. That's why you're looking from your observation to that point. The radius is going to be the line that's parallel to the plumb right there.
So your formula we would put in
guys,
90.
Quick, I'm in a good spot. Real quick, why are we even looking at the horizon? That's not the curve of Earth.
Yeah, I know.
So why are we even looking at the?
We're not meant to say. We're not saying anything about the curve of the Earth. We're talking about the radius.
All right, go ahead.
Have you got this now, Bev?
Scott's up here. He's up here at the top of his 100 feet up, and he's got his angle. He's looking out, and he's going, Kosho, I'm 333 feet up in the air, and I've got an angle of, I don't know, what do you reckon?
To the horizon.
A second or two, maybe.
7.
I don't know. I've got a couple of seconds, maybe a minute. I'm not sure, Kosho.
7 seconds away.
Yeah, come on, Kosho.
Where does that say that in the aviation manuals?
Kosho. No, we're not. He's not flying. I mean, he normally does do a lot of astronaut flying, but
if I
no.
want to fly straight, I need to know that angle, wouldn't I?
Come on, Kosho. I want to draw a circle underneath me, but I don't know the radius. Please work it out for me, Kosho.
Is
No.
he even still here? Is he gone? Oh, okay.
I think he fell
I
off.
mean, I don't know how you guys can't see that when Bev is helped, he doesn't help himself. There's no point in I mean, I've given you everything you need, Bev. I even tried walking you through it. You don't want to see it. It's in the pay. It's on the thing. I posted it probably 12 times. It'll be there for you when you want it.
Oh, you're not going to help us,
Kosho, you
Kosho.
can't draw that
Yeah, I tried,
circle.
Bev. I just tried. I tried several times, Bev.
Oh.
You just said you can't draw a
It's a
circle. So
logical fallacy.
what are we gonna do?
It's a logical fallacy to draw that circle if that's what you're trying to prove. That's begging the question.
Drawing the circle is not going to represent. Is not in any way describing what the Earth is. The equation is what's going to represent it. Drawing the circle is just to show you where the variables go. It's not gonna. You don't have to think of the Earth as the size that it is. Like in the page that I drew, it's not to scale whatsoever. It's not a fallacy because it's not part of the argument.
It is. It's a begging the question is a
To be
logical
a fallacy, it would have to
for
be an
a
argument.
reason.
It's a description.
You're trying to get
I
the
get it.
radius. You
He
can't
might-
draw the
look,
circle.
Look. Just.
You are citing to an apparent position. How can you possibly
If
get
it might
any
aid you.
measurement from apparent position?
I've put a circle there for you. It's even all divided up into degrees for you, right? Go on.
Yeah,
does
draw a
that
building on top of that circle.
does that help you?
Yeah, it's fine. Draw a building on top
No,
of that
no,
circle.
Scott's already up at the top
Draw
of
a
the
building on
building.
top of that circle, Bev.
Scott's already
Alright, I'll do it. Don't worry about it.
done his building. Scott's already up his building. He's measured an angle. I've just put that circle there to give you a bit of inspiration. Like you said, it doesn't matter. You just want a circle there. So I put a circle there to give you a bit of inspiration. Now, can you please tell us how you can easily measure the radius?
Draw a building on top of the circle, Bev.
Will that help you measure the radius?
Bev, if you draw a picture on top of the circle, that'd be great. If you don't ask me to do anything else. Don't ask me to keep doing something that I'm telling you how to do that you're not going to do.
Big MLO statue. There you go.
You cannot cite.
Yeah. Now draw a line from the top of that observation point down to the where it meets the
That's
circle.
what Scott's done. Scott's already done that.
From his head. Make a tangent line from his head to the surface of the circle.
What? A tangent line from his head to the... That's what the angle that Scott's already measured.
Yeah, make a line from his head. Make a line from his head to the first point on the circle.
Sorry, wait a minute.
Make a tangent line from there.
Kosho, please stop that. Naps, dishonest, where? Go on. I heard you say that somebody was dishonest. Who?
Well, Naps is
Yeah.
Naps is full of shit. She's in way over her head and has no idea what's going on here.
Naps?
Alright, let
Who's
her
dishonest,
explain what's
Naps?
Dishonest, because I heard it too.
Yep.
She bounced.
Oh, she disappeared?
She disappeared.
Oh.
Well.
I'll tell you what's dishonest is citing
No, she
something
wouldn't
to
have
an
got
apparent
Yeah, I
position.
kicked him
There's
2 days
no
ago.
physical way you can say where that
Yeah, she was
apparent
being sexually
So
vulgar
how
in the chat.
can you possibly cite to an apparent position? You can't.
Yeah, you're not measuring the distance to the horizon, which can vary by a lot due to refraction. But the angular dip of the horizon doesn't vary by very much.
Your measurement
Yeah, but you're not measuring the angular distance to the horizon. I mean, you're not measuring the distance to the horizon. You're measuring the angular dip, which doesn't change by very much due to refraction.
Is there?
You're deluded, man. Absolutely.
Okay, how much did I do to refraction then, Brian?
You are deluded. You don't know what.
Don't know. That's why I'm telling you that it doesn't change by much.
From 1 minute to the other, it changes in depth. It gets greater or smaller.
Yeah, it doesn't change by much. I said the angle doesn't change by much.
Point to fucking measure to, you fucking lunatic.
Yeah, the angle doesn't change by much. I'm telling you this because it's true. The distance changes by a lot.
How do you quantify it, Kosho?
You're not lying to us. You are lying.
You use
to
the angle.
yourself.
The amount that it can change by will depend on the amount of refraction that day. But it's
Kosho.
enough to still get you. It's enough to still get you within the ballpark.
do this
of what the
radius thing. Come on.
Lying to yourself, not us. We think you're a fucking idiot. You're lying to yourself.
All right. Well, I suggest you try this and then see if it works or not before you claim that someone's lying to you. Because everybody else in the world who understand this, it makes perfect sense and it
We
works.
know you're a
But
fucking idiot.
or I
You're
could be lying.
to yourself.
Yeah.
What happened to the pear shape? The pear shape. Your Pope said it's a pear shape.
You're a fucking idiot for saying that you can measure to an apparent position.
And everybody in the world doesn't know this, Kosho.
I said everybody in here who does know it. I said everybody else in here who knows this equation, who knows this formula, they don't think that it's a lie. They have no reason to think that. It's a perfectly reasonable thing. Even Jay Tolan had discovered that.
No, Kosho, you're just trying to fantasize something out of nowhere.
I mean, I've looked at the numbers. You can look at any numbers that you can find, any altitude with the angular dip of the horizon.
You can do loads of numbers.
See if it works or not.
Yeah, you can write
And
any
sight to an apparent fucking position, you idiot.
Right now, you guys are all denying it without having tried it once.
Brian's right, Kosho, by the way.
There.
We haven't tried what, Kosho?
But that's okay.
Said
it was easy.
It's an apparent position, Kosho. It's not real.
What?
Apparent positions are real.
It's an apparent position, and you use that apparent position
I'm
to get these.
I'm ready and waiting to try this, Kosho. Tell me what we are doing.
So what happens with the bulge on the equator? What happens then with your fucking maths? What happens then with your pear shape? What happens then?
Is there a drunk person in here? I don't know what he's talking about, but
Kosho, could you drive to the horizon and put a flag in the ground?
Pieces of information. Use the 2 pieces of information that I've said that you need to do this. You can do it with a drone or a sextant or any other tool that you can measure the angular dip of the horizon.
Can you see my camera? Can you see my camera?
Two things.
Can you see?
I'm not looking at your camera, Bev.
Right. Well, I've got a sextant here. Right. Now,
That's fantastic.
imagine I hand this to Scott, who's at the top of his 333-foot mountain, and he's looking out and using this to sight the horizontal, and then measures an angle here, like you said. What the fuck do we do with this angle?
I've already told you, Bev, and one of your friends can try to tell you. And
No, you were in exactly the same position that Roohif was in.
I'm not going to keep explaining.
And right, Roohif couldn't do fuck all with an angle either. Because you can't.
Kosho, you haven't really explained anything so far. All you've said is look at the formula.
I've explained several times how it's done. You need those 2 pieces of information. You need your height, which can be found by, I don't know, measuring how high you are. Then you can see the angular dip of the horizon by measuring with the sextant in reference to the horizontal line, a level horizontal line to the
angle
the
here.
angular dip of the horizon.
Yes.
Don't talk, Bev, because then I got another person saying I haven't explained this again, and you're talking through it again. Then all you do is you use the formula at the bottom of that page that I posted. The proof for that equation is right above that. You use that equation, you plug in the numbers. H, your height, times cosine of the angle, over 1 minus cosine of the angle. Will give you the radius, the R that's missing in that picture.
What, the cosine of this angle minus the cosine of this angle? Was that?
If there's a mountain
Rodney
horizon.
Trying to say something. That's all.
It's just ludicrous, Kosho. If there was a mountain range, the horizon would be a lot higher than if there wasn't. It's ludicrous.
Rodney B, were you trying to say something?
Oh, yeah, I was just going to say you can't, like they said before, you can't measure to an apparent position. That's not a measurement.
Exactly.
It is a measurement. The only thing that goes along with the measurement to an apparent position due to refraction is going to be the amount of error that you might receive from that refraction. But as I said, with a distance to the horizon measurement, you may get a lot of
distance to the horizon measurement.
Don't talk.
Where'd you get
you may
distance
get a lot of
from?
error. Stop talking, please.
Well,
you may get a lot of error. Dude, stop
the
talking,
distance.
for the love of God. Like, I'm talking to a different person, Bev.
Yeah.
Ask your question to him when I'm done talking to him. I'm in the middle of saying something to him, dude.
Okay.
You can measure the distance to the horizon and get refractive error, but that refractive error is going to be whatever it is if it's low to the ground, but usually if it's high up, it's 7.6R, which could be a lot. But with the angular dip of the horizon, it's not varying by much. Not much that's going to change this, not enough that's going to change this observation.
Okay, so
the measurement to the radius.
So I have a question.
What if the horizon is above you? If there's a mountain range in front
Let
of you,
let Rodney go.
What happens then?
Then you're doing it wrong.
Oh, I'll move the fucking mountain, will I?
No, you go to a different place. You're doing it in a wrong place because you're doing it wrong.
Complete fucking twat.
Kosho, can Rodney respond to your statement, I guess.
I hope so. If other people don't want to talk through it.
Oh yeah, sure. So you said that you take the refraction into account when you're measuring the dip angle to the horizon. Is that right?
Yeah, you could take it into account, and it would definitely make it more accurate. But like as I said, the error that you get from refraction
would already include the radius value.
No, it's not included. No,
7/6.
But that's what I'm saying. Is it's the same thing with the when you're doing the geometric horizon, distance to geometric horizon equation.
Do you don't use 7/6R then?
You're not listening to the question,
refractive
Kosho.
index. Stop talking, dude.
No,
like, if I'm responding to this,
you're
guy,
not
just don't
responding
talk.
to the question.
Never mind. Forget about it, dude. Forget about it.
7/6R. You've already got your R
Yeah,
in there, mate.
do you not use that, Kosho?
Where do you think the R comes?
Thought that's what we were trying to figure out.
Mm-hmm.
Yeah.
Talking, but
He says he doesn't use it though, so.
To figure out the dip
But you're just rambling. You're not answering the question directly. You're answering it wrong. He said, you've already got your R in your refractive index.
I answered that question. Somebody else did.
Yeah, Rodney did. But you're not. You just keep
Somebody
talking.
else answered that question. Was just asked, and Negator had answered that question.
Okay, can I?
Just let Kosho and
Go for it, Bev. Go.
Well, Rodney, are you done? Because you said he measured the dip angle. He didn't say that. He said he measured the distance to the horizon. How do you do that, Kosho?
The distance. I was giving an example of when you measure the distance to the horizon.
How do you measure the distance to the horizon? That was the question.
Less of an error that's going to be relevant.
Measure the distance to the horizon.
You said when you measure the distance to the horizon. The question is that I'm asking you, how? How do you measure the distance to the horizon?
Anymore, Bev. I'm not doing this with you, man.
Pardon?
I have the patience for it.
Is that no? I can't tell you how I do that. I just state that I've just done it, just like I did with the radius. It's easy. It's easy. I just state that I can do it without knowing how I can do it. Everyone knows, Kosho.
Right.
You obviously send some.
The retards online know it. That's right. Just like you guys know everything else.
Are you measuring the distance to the horizon with a cosine angular calculation? Is that what you're doing?
No. The distance to the horizon is not a measurement. It's not the result of this measurement. No.
So what's it in there for?
Where'd you get it from then?
The distance to the horizon is not a part of this measurement.
How do you calculate it? Where'd you get it from? How do you measure it, please?
It's
a totally different subject and a totally different way.
Are you measuring or calculating?
So have you ever measured?
Yeah, absolutely. It's fairly easy.
Measured the distance.
It's fairly easy.
Fairly easy.
How would you measure it, Kosho?
Did you
just say it was easy?
Yeah. It's all easy. He just doesn't know how to express it.
Oh.
He can't tell us.
It's trigonometry. It's not measurement.
It's easy.
It's not measuring anything.
It's easy. You just obfuscate for ages without saying anything. It's easy.
And with their oil rigs in the picture, you can know how far away those oil rigs are.
Just imagine it. Just imagine you can do it, Kosho. Imagine you can do it. It's easy. It's easy when you imagine it. I can imagine it.
Kosho, your ludicrous fucking ball.
Well, ask me a question, then Beth starts talking.
Your ludicrous ball is falling around your ears.
Here's an example of being at an altitude on a mountain, knowing what distance that mountain is over there, and being able to know where the horizon is in this picture.
Altitude on a mountain?
How would you measure the distance to the horizon?
Remember, Kosho, you have to take in 7/6R, so you don't know the distance, right?
It's weird that the subject of angle of the horizon has been dropped entirely in favor of distance to the horizon, despite that not being what Kosho was talking about.
True.
Exactly. That doesn't matter to some people in here are drunk, and some of the others are just trolls. So
yeah,
it's going out of nowhere.
It could be.
Which one are you, Kosho?
You know,
yeah, I'm paid to be here.
You lose my patience is the one I am. I'm the one politely trying to explain something to the people who want to know, and having to put up with the people who have nothing to do except for obstruct the conversation.
Whoa, well, what's that picture there, Kosho? Is that a new one? Where did that come from?
Kosho, I've already read everything that you're telling this panel here. right? I've read it. I get it. I've looked through
But
the
you're not
math
even a real
on it,
flat
right?
earther.
I've already read it. Okay. Now, real world application, practicality, have you done it? Or has anybody done it?
Yeah, absolutely.
Okay.
It's not
There's
hard.
a couple folks on this channel that actually are surveyors, right? So you might want to listen to them and see what their knowledge is before you keep just repeating what you've read on the
I know
internet.
the extent of his knowledge, and it's not something that it's worth listening to. And I feel bad for the people that he's
You've sat in a Discord channel, haven't you? You know loads, Kosho.
I know, Face, that you're not one of them because you're not a flat earther. You're just pretending.
Listen. Rodney, if you
That's what it comes down to. We're just
Sorry,
pretending to be
sorry,
flat.
you're dismissing me because you say I'm not something.
Talking to you, Bev. I wasn't talking about you. I was talking to Face.
Kosho.
You're a real life Glober. You're a real life Glober.
You trying that hard?
We are pretending flat earthers. You're a real life Glober, right? You're a real life
Face, I
Glober.
didn't say anybody else in this room. I said you specifically. You are the one who's pretending, and you know you are. So
Sorry.
There's no point just continue talking about it, man.
Why would you say that? But
Kosho.
You've admitted as much, man.
Like who? Patient Zero. Who are you talking about? Like, what's he doing? Kosho, are you talking to me or are you talking to Patient Zero?
I'm not talking about you, Bev. You're not included in this conversation because it's not about you and it's not in reference to you.
Right, so you're just talking about me while Aaron's talking a load of shite, and neither of you are talking about anything.
To you, I'm not talking about you, Bev. You're
sounds
not
like
involved.
Oh, right, you think you could just come here and talk about me while I'm in the room, and you think that's a valid topic of conversation, do you?
I don't know how many times I gotta say it. It's not about Bev.
Well, why are you talking about me then?
Just interrupt.
He's talking directly back to me. For some reason, you think that that's you.
Sorry, Kosho, guys, can I just say goodbye? If anybody's got any spare prayers, my dad's unresponsive in the aged care home, so I'm popping into the big town to see if I can. They'll let me in now because they wouldn't let me in to see him because I hadn't had a flu shot. But now she said, oh no, come in, we'll just cover you in PPE and you can go in and see him. So I'm off to go and see him. So yeah, any spare prayers would be greatly appreciated.
Good luck with that, Donna.
Blessings sent your way.
Thank you all. I'll see you all tomorrow probably.
See you, bye.
I suppose I'll be the first one. What a moment of silence, right?
Maybe everyone's praying, Aaron.
Let's be respectful, exactly.
Let you know what really matters.
Everybody's roboting. Can you all drop and then come back in, please?
Kill the video.
Now that
Kosho, who is it that's the baller, Kosho? Is he saying that Face is a globe earther?
Well, I was saying that to him. I don't want to. I mean, yeah, but this is.
So Face is a glober. You want to respond to that, Face? You agree, or you've been accused of something?
I think we are all roboting. I heard a bunch of roboting.
Whose faces?
Did you guys see the SpaceX crash today?
Clear as a bell for me.
Whose faces?
Yeah.
Launched the rocket and it came back down. And blew up.
Aaron, are you a glober?
Yeah, I'm gonna jump out and jump back in. Flip flop real quick. Hold on.
Oh, so you got fucked up, bro. You tried to use 7 over.
Did he just say yes?
7/6.
He says go
I'm not sure, man.
He did, didn't he?
Yeah. He didn't deny it.
No, yeah. He went, yeah, I'm just gonna...
Flip-flop.
Yeah, I'll just flip-flop. Be back in a minute.
Bev, come on. Come on. Hold on.
Roboting.
Wow, Jeremy.
Kosho's on the hot seat, not me.
I didn't ask, yeah?
State your position, Aaron. You've been accused by Kosho.
Yeah.
Was that who asked me? Because I couldn't. It was roboting, like Travis said. I couldn't hear, so I was like, "Yeah, I'm gonna jump on."
I think that was Bandsaw.
No, that was Effie.
Oh, it was Bandy.
Oh, was it?
No, Bandy.
Wasn't me. No.
Chris, hang on, mate.
No, but
It was.
Don't bring Bandy in.
It was Kosho. Kosho has accused you of being a baller, Aaron.
Yo, am I good now?
Say again,
Come on.
Bev. Sorry, I'm cutting out.
Of metal, Aaron. Stand up for yourself. Right, stand on that little X that we marked out the other day. Get good reception, and stand up for yourself like a man.
This is the moment of moment of the truth.
Aaron, Bradshaw, what does this?
I think Travis is right. Everybody needs to just, drop off and come back in because y'all are roboting real bad.
I haven't heard any one person robot.
No, I haven't. Jeremy, maybe.
Not me.
Guys, am I roboting?
You sound better now.
No, you're good now.
Yeah.
Maybe he's just on the cusp.
No, Jeremy, you need to come out again and come back. You're bad. Go over to Jim's server first, and then come back.
Aaron's just messing with all y'all.
Mr. Bowfingers.
Come on, Aaron. Make a stance. Come on, here's your moment of glory.
Okay, what's my stand? Where am I? Where
Are you a Glober, Aaron?
Yeah, you are Kosho accused.
You of being a Glober.
Confused Glober. When was I doing that?
Oh, 2 minutes ago. He said you are a Glober and you've admitted it.
Well, I didn't know who said that, and all I was
Kosho
worried about
said
was
it.
what Travis had just said was everybody's
Aaron.
roboting, so...
You've been told 16 times who accused you.
33 it was.
I'm a Glober. All right.
Not 33, sorry, Bev. Yeah.
Listen, y'all got me up against the wall. Got me up against the wall. I'm a Glober. Now what?
No problem. We all were once.
Yeah.
You will make it. We're here to help.
No, I was Glober, then flat, then now I'm Glober tonight. Apparently.
Give me your proof.
Troll.
Now,
Troll confirmed.
What's that then?
Kosho. Kosho, you got
Slow show. Don't say Kosho. It's slow show.
I thought we were having a great go round with Kosho.
No, slow show. Y'all got it wrong.
Even
Slow
though it's
show.
useless because he can never admit to anything.
If you can't see through those complete and utter fucking nonsense, then you need to stay as a fucking Glober.
I'm Jeremy.
Hopefully not.
Bro, you got so fucked up just now. You were in the middle of trying to prove a R, and you used 7/6R.
No, I was showing how to measure R. I wasn't trying to prove R.
You were trying. No, we don't believe that you can measure it. You need to prove it.
Right. So I'm not trying that technique doesn't show you how to prove R. It just shows you how to measure R.
How do we prove it?
Hey Travis, is that better? Can you hear, Travis?
Yeah.
Hold up.
Never mind. You can't get anything done here.
So it doesn't prove R, but it lets you measure it. So it gives you a measurement for R. Wouldn't that be proving it?
That doesn't make sense.
Yeah, and it's still not a measurement. It's still a calculation.
You just don't understand, Brian.
It uses 7/6R.
Yeah. It's a calculation that you have to put R into the fucking calculation.
R is at the end of the equal sign. So if you notice that
Come on,
R
Brian,
is
catch
one
up.
side of the equal sign, and then the other side of the equal sign is the values that you know.
It's got R on both sides. How's it? How did you
There's
do
not an R on
that?
both sides. There are no R.
It's R plus H.
There's an R by
Brackets
itself
cos
on
A
the side.
equals
There's
R.
an H cosine over 1 minus cosine A on the other side.
No, you don't know
R
about
is what
cosine.
the answer is, and the other side is the numbers and values that you've measured.
But it's not proving it, it's measuring it.
That's right.
How did you measure it?
But if we didn't measure it, yet, how do you
measure it, Kosho? Do you know the difference?
Is my mic working? Check.
Yeah, you measure the height that you are, and you measure the dip of the horizon, and you plug that into the formula.
And you assume R.
You measure your height. What else do you measure apart from your height? Sorry, I missed that.
You measure the dip of the horizon from that height.
How could you measure that?
Sextant with the theodolite with.
That doesn't measure anything. You got to measure.
Yeah, you
know the
reference.
You know what
you reference,
measure means. You know what measure means,
the angular
Kosho?
drop. You reference your horizontal,
measure.
And you look at
Measure.
the angular dip of the horizon from that horizontal.
Hello, check. Measure.
Measure
means.
means.
You know what measure means?
Coach Joe. He's right. It's not possible to measure angles between objects. He's 100% right. Yeah, no, you're entirely right. It's impossible to navigate via maps and compasses, which also use angles between objects. It's impossible to measure angles.
Here comes the obfuscation.
To the horizon. That's what he's talking about.
Measure.
No, you're right, man. You're right.
Can you see that formula there? Right in that formula, he has got sine COA of an angle and all of that, and then he's got
angles
he's got
don't exist,
sine
right? You can't actually measure
90
them.
degrees minus A brackets equals R over R plus H. So there's two sides of a triangle, and they both seem to have R.
Oh,
already
how do you know it's a
in
triangle
them.
if you can't measure the angles?
Like R. You know, like in order to describe a circle, you need a center point and a distance from that center point, commonly known as R. Right, that's what you're trying to find out, but like you seem to have already got two of them in your triangle.
Bloody convenient, isn't it?
How's that work?
You guys can't be that stupid.
Yeah, they
When you look
really
at the
are.
equation at the bottom, it shows you R's on one side of that. The R in that triangle on there in the picture is the thing that you're trying to figure out. It's a thing that's not known.
Yeah, you've put two
The thing
of
that is
them
known
in
is
your
the
triangle.
angle A.
Exactly.
Use the H and the angle A to find the R. It's not hard to understand unless you're trying your hardest to not understand it.
Sorry, you're using that angle of them R's to find the what? The angle above. Because look at it.
Bev, you're
Gotta
cutting out.
save
Bev.
this.
Bev, you're cutting.
No, he's good.
You're good, babe.
That sounds okay to me.
Yeah.
The problem is,
Okay, you're back. Bev, you're back.
You not see the angle there? That angle A, the one measured at the top of the mountain.
Oh wait! I thought Vangelis just said you can't measure angles. Was he not right?
Who said? Nobody said that.
Oh, well,
Nobody
Vangelis did.
said that. Somebody came in trying to obfuscate, saying that somebody had said something that they
He
didn't.
didn't say that. He said that's not a measurement. He said, how do you measure with a theodolite? And I told him, and he said that's not a measurement.
Vangelis, do you want to explain that or no?
Did I not just show you a sextant that can measure an angle? And that's
Well,
what
yeah,
exactly what
sextant or
Scott
theodolite.
Peach did at the top of his
You're not arguing with your
333-foot
flat earth
building.
views.
Sounds like you should show Vangelis
Does
that.
anybody else think that Negator sounds like talks with the same cadence as Bambino?
Why don't we focus on the argument?
Everybody's cutting out. Brandon must be going through that electromagnetic storm.
Nobody's cutting
out. Shut up.
I heard that Negator was one of the best globe Earth heroes, even originally.
Heroes.
Yeah.
He's one of the best debaters. He keeps calm. And
If you want to be specific, Nick,
That's exactly it, Kosho. When we
what
were
I
doing the
said
debates,
was you
he's
can't
the best.
measure a distance with a theodolite or a sextant.
no one's trying to measure a distance with it.
Yeah, well, there
Cool,
you
because
go.
that's not what Kosho was explaining, Vangelis, which means you have a difficulty hearing.
You cannot measure to an imaginary horizon.
Yes.
Ludicrous.
You can't get a distance. That was the thing, right? So all we had was the elevation
It's almost like it doesn't matter how many times you say
I
the
know,
same
right?
thing.
and an angle.
It's like they're just not
It
listening.
depends what you're looking at. If the horizon is higher than you, then it all goes to shit.
I thought you guys understood all of this trigonometry and stuff. I mean, come on.
Kosho, it's ludicrous.
It's easy, you said.
It is easy.
It's easy, and it's also easy to measure a distance to the horizon, right? But you can't seem to easily describe how you do either.
You know, somebody told me that you were a geometrical genius. They said this to me the other day, and then I almost turned white.
That's very nice of them. I just know the fundamentals. That's all I say.
We corrected him.
The basics.
Yeah.
And
he
I hope
he
you
was
did.
Here a little bit ago.
He said
Bev
just has a fundamental understandings of the very basics of geometry.
Yeah, you can't even understand this, and it's been drawn out and shown to you like 15 times.
Well, that's what I'm saying. I'm like, I just understand the basics. So if you would like to progress me on and show me what we can do with this distance that you've just done and the angle, well, like, show me how to progress. I do not understand how to progress myself with the limited knowledge that I have of this subject. I'm obviously far behind you. Now here's your chance to shine. And then I will be able to show other people then how to do this. I will develop a method to help people understand how we do this. But I need you to show me how to do it first.
Sorry, I'm off. I just clocked out.
Let's go through this count. What is R plus H?
That's the height. That's the altitude that I am. That's the 333 feet that Scott is at. Right.
And what's the R?
You have that full distance. If you had that full distance, then you would have the radius plus your height. Because it's not known, it's what you're trying to figure out.
Yep.
That's like if you look at all the equations that lead up to the last proof, to the last formula, those are the derivation of how you get there. So it shows you at the where it says sine of 90 degrees minus A equals R plus H.
I think I've seen this. This is perfect maths, isn't it? Let me find it. There's a meme somewhere. Fight the flat Earth, perfect maths. I knew it looked familiar.
So what about?
I knew it looked familiar.
So what about in the very first step? What's the C to O and A to O? What are those values? Are they always the same?
Those are always. I mean, those are always going to be. Let's just see. You're not going to know what the angle to 90 degrees is 90 degrees, so that's already known. And the R is what you're trying to figure out. But the distance from A to C is it's not needed at all. But by figuring all the rest of them out, you will inadvertently also obtain that distance.
It's easy though.
C to O and the A to O. What are those two values?
C to O and A. Yeah, A to O. Those are the values that you're trying to figure out. That's the those are the easy part. Those are the distances that you're trying to figure out.
How do you know there's an O?
Well, you're going to start off from that. If you don't think that the Earth is a sphere, then you wouldn't use this equation because you wouldn't be trying to figure out a radius.
So why would you think the Earth is a sphere? Right.
Well, you're assuming it's a sphere to start with.
Of course he is.
From the position of already knowing it's a sphere and using this to find out what that
How do you
radius
know it's
is.
a sphere?
By the other
proofs. Yeah. The other what?
Which are?
No, I'm sorry, Kosho. I said, how do you know it's a sphere? I didn't hear what you said. What'd you say?
By looking at all the other evidences that show
I'm asking
GPS is one example.
you for one, Kosho. Can't you express yourself?
Yeah, so GPS is one example.
No.
Both the way in which it's obtained the locations and the fact that it gives you degrees as coordinates.
No, we're not using a system that already incorporates a spherical model. I'm talking about before all that shit. Before they had all of the math to graph out GPS, before they got there, how did they know it was a sphere?
I'm trying to answer your question, man.
How did Alberuni?
You're just like that. Stop talking, and then you would have heard the answer, dude.
No.
Stop talking, and then you can hear the answer,
I'm not
man.
going to stop talking, Kosho. I'm going to try to.
Then what the point is trying to answer? Then you don't want the answer.
He's not asked the question yet.
Okay, settle down. Kosho. Listen very carefully. I asked you a question, and you went to modern mechanics.
You have no way of knowing what my answer is, man.
you've given us right now this little diagram for Al-Biruni. Okay? Fucking Al-Biruni didn't have fucking GPS. Okay?
Yeah, that's
so.
So if you let me finish,
Okay.
What GPS gives you is degrees,
shut up.
because those
Just
degrees,
shut the fuck up.
those degrees are representing. No, this is like, dude, no, dude.
This is
If
what
I ask
he
a question, I'm
does.
going to answer it,
Kosho.
and you can argue against what the answer is instead of what you think the answer is.
I'm going to object, Your
Yeah,
Honor.
those. It gives it
Five,
to you in degrees. because-
5 seconds.
Right.
5 seconds. Oh, there it is. There it
Gives it
is.
to you.
You found it.
I
There
love
you go.
people who say you won't let me finish while they're not letting you finish. I love that, Kosho. Good work.
There you go.
Easy.
Does that look familiar? Look.
He interrupted me 5 seconds.
The perfect maths from Fight the Flat Earth.
Fine, finish interrupting me, please.
I don't know. You were interrupting Travis, so I don't know.
No, I wasn't anybody. I was answering him, and I got interrupted 2 seconds into it.
It's got. Fight the Flat Earth went with the H derivative of that thing. Look. Look, Kosho. Look.
Fantastic.
It's the perfect maths.
So the reason why, the reason why longitude
he wanted to find out how high you were.
The reason why it's referenced in degrees is because they're coordinates.
You use it to work out your altitude.
My God, Kosho, are you?
Don't try to ask me a
You've
question.
got to be a fucking idiot.
I'm trying to answer your question, dude.
Okay.
Please just stop talking.
You
For a
have
second.
got.
It takes 2
okay,
seconds. It takes 2 seconds to explain it.
The fact that
It
you're
takes 2 seconds to
referencing
explain it.
the fact that you're referencing longitude and latitude and spherical coordinates shows either that you're a fucking idiot or you're intentionally obfuscating the discussion. Which is it?
He's deceiving.
Which
All
is
right,
it?
so I'm going to finish up now.
Which is it?
The
I
reason
have
why
a
it's given in
question.
degrees.
Objection,
The reason
Your
why it's given in
Honor.
degrees
I
is
withdraw
because
the
they're
original
coordinate.
question, Your Honor.
That's fine. That's absolutely fine. The reason it's given in degrees is because
Objection, Your
it's a
Honor.
spherical
He's
coordinate
answering a question
system,
I've withdrawn.
and you can know this. You can know this by looking at the. Dude, stop! Would you stop, please?
No, you stop.
Like, for
I
the
don't
love
want
of God.
I don't want to know your answer anymore.
Okay, well then close your ears.
No, you stop
For
talking.
fuck's sake.
For fuck's
No,
sake, you.
no,
yeah,
dude.
Yeah.
That's not how it works.
Can you let him
Actually,
finish?
no.
I don't want to ask a question.
No one else wants to hear your answer right now, Kosho. No one.
I do.
I want to hear the Al-Biruni answer.
He doesn't want to give it. He wants to talk
sticks.
about spherical coordinates and longitude and latitude.
You asked me how I know it's a globe, and then you didn't want to hear the answer, so there's no point in saying anything else to you, man.
Yes.
Just like Bev.
Fucking idiot.
So can I ask a question, Kosho?
That really depends, man. If you're gonna do what he just did.
No.
But yeah, sure, go ahead.
No, I'm not gonna do that. So in the very beginning, you told Bev to put a house on a circle on a ball. Why would you use that if?
I said it one more time. You said that one more time. I'm sorry.
Oh, in the beginning, you told Bev to put the house on a circle, right, on a ball.
Right.
Well, you know that house was built using a coordinate system that's not latitude and longitude, right?
No. The only reason I was telling him to make it on the circle is because he was asking to draw the picture that I had posted about 15
He's not
times.
answering the question.
It's Kosho.
You didn't fucking
Fuck's
answer his
sake.
question, Kosho.
Guys, dude, stop talking, dude. You just stop talking. No one's talking to you.
Asked you
So
a question,
leave the conversation.
and you're not
I know. I'm trying to
answering
answer his question, dude. I'm answering his question, dude. I swear to God. I hope that you just stop pressing your fucking talk button and stop talking so I can respond to him. Yeah, the reason I was telling him to make that circle is because I was trying to describe the thing that was shown, the picture that I was posted to him. He couldn't see it because his camera was on, so he can't see it for some reason.
Objection,
So I was just
Your
describing
Honor.
him how to
He's
make
still
that
not
picture.
answering the question. Did you not hear his question, Kosho? Because the answer you're given is not the answer to the question he asked you. He asked
So why
you
don't
a
you
question.
answer? Why do you answer it
He's
then, man?
not asking me.
I've got
Yeah, I already understand why you put it on the circle, but I'm just pointing out that in reality, that house was built using a coordinate system that's not latitude and longitude based.
Doesn't need to be.
Say it one more time.
I'm saying reality doesn't match your.
Over that bit. I've
what
got
you
a
told him to draw.
we
No,
take a
that's
measurement?
incorrect, Rodney.
No, it's not. The house was
Could we
built using the
could we
easting and
take a measurement?
northing coordinate system, not latitude and longitude.
Right, but it doesn't need to be in order to support his point.
Could we take a measurement from a cloud, Kosho? Would that work?
really wish all you guys the best of luck, man. I mean, I'm being honest with you. Like, I hope that you guys are just pretending or you're just being silly right now. But wish you the best of luck, to be honest.
Could we
No,
take
all
a measurement from
we
a
all
cloud?
understand. You just have to presuppose and pretend you're on the ball first to make your stuff work.
Right.
We get it. We just know it's not reality.
We measure it, Rodney.
Can you measure it from a cloud?
I actually do a little bit of measuring myself.
Mm-hmm. And
I don't use any of the math that you're putting up.
Oh, do you measure something that would matter in this context?
Oh yeah, I'm a surveyor.
Well, the question still stands.
Yeah, I answered your question. Yes. What do you think?
No. We're talking about a specific point to point, something where the context of Earth
You're
would
not
matter.
talking point to point. You're talking point to a parent point position that can change. That's not a point to point.
Okay, so what have you measured?
What have I measured?
He's a surveyor.
Yeah.
I'm a surveyor, dude. That's what I do for a living. I've measured a lot of things.
Okay.
First order.
Like
right?
what? Because a plane surveyor wouldn't measure something where Earth's curve matters.
Damn right.
Which then gives you, like, you can claim you're a surveyor, but if you don't survey anything where curvature would come into play, then your claim doesn't hold any water. This argument.
Well, like the surface of the Earth, does that count?
Yeah.
How long a surface?
You mean like distance? How far?
Yeah. What sort of distance do you,
10,
when
12,
you do your
15
plane
miles,
surveying? What sort of distance do you go to, Rodney?
I mean, in one section, at longest 10, 15 miles.
You wouldn't see any curvature, would
So
you?
that would that be a horizontal that you work on that plane?
Yeah, and the whole horizontal plane coordinate system that we use is much larger than that.
Yeah. Right. So
you have to give me a minute. I'll be right back.
Is that what you're talking about? Oh, you've gone. Oh.
Run away, Nick. Run away.
Wow.
They'll all do a runner now.
Wow.
Dang.
Well, in 11 miles, there's supposed to be 150 feet of drop.
Come on, Rodney.
Right, but what he didn't say is what he was measuring over those 10 miles.
A horizontal plane, he said that's what he was working with, right? He was working with a horizontal plane over that 10, 15 miles. But he said the actual plane that he uses is a lot larger than that.
Yeah, like probably 110 miles by 300 miles long.
Ooh.
The Earth does not curve. Get it in your fucking heads.
Ours doesn't. We have rail guns.
It's like
silence.
Not at a point that's like for the whole area. Like do they call it state plane?
Yeah, that's the state plane.
Yeah.
Yeah, what you didn't do is tell us.
But like
your methodology.
a plane, as in like a two-dimensional mathematical geometrical plane, like a flat surface plane.
Well, we use X, Y, and Z.
Yeah. Yeah, it's like because I'm predicting soon that the globe Earth imaginometry people will start wanting to make a curved plane. I can see it coming because they're going to need it, right? They need bendizontal, and in order to do that, they're going to need a two-dimensional curved plane. I mean, it's already in the making because they want to show that a surface of a sphere is a two-dimensional surface, which it obviously isn't. But I mean, this is the progress that where we're going.
They couldn't work with that. How could they ever survey off a curve?
They don't work in reality. Like the people that work in reality, like Rodney, people like me, builders, and they actually use it. I mean, they know, but it's just these people that sit in Discord internet chat rooms, like discussing amongst themselves how their model must work. They're the ones that decide about all of these things. I mean, they also seem to think that they hold the popular opinion as well. And I don't know. I think it might be because there's a few more of them people in their Discord group that they think that they're correct. I mean, just today we heard Roohif saying that the dictionary isn't, it may be popular opinion, but it wasn't his popular opinion. So he was willing to go against what all the dictionaries say because he didn't agree with it. So therefore, definitions are meaningless if Roohif doesn't agree with them. But
he's rewrote the dictionary.
There's a lot of people that do that now. A lot.
Well, Nick, would you claim a greater knowledge of surveying than people that do it for a living? Do you think you have more knowledge than people who actually do this all day, every day?
Me?
Well, I mean, I do actually do this.
No, Nick.
Oh.
You do this you're a surveyor, Nick.
I think most surveyors are flat earthers.
I wonder why.
Answer the question.
I mean, it would sound a fair question if that's not true. If it's true that most surveyors are flat earthers, then I'd say, yeah, I guess I do. I guess I do disagree with them. I don't think that surveyors think that. Yeah, there may be one or two, or some people who took a surveying class, and one guy that does it, but surveyors don't think that the Earth's flat.
Kosho, why are you even talking? He asked.
Neg, are you still in the?
Yeah.
Yeah, Neg, are you still in the conversation, or are you on mute? I can't see. I'm driving. So, are you still here or not?
I don't see a Nick.
He's still here. Negator. Mr. Buff Fingers. He's still in here.
Buff Fingers,
He's not coming off of his mute yet, though.
Is he deafened or?
Yeah. He's no, he's not deafened. I mean, he's just, obviously he can't answer you because, he's not a surveyor and he doesn't know what he's talking about. Like I said, I think I described it quite well, right, Kosho? You sit in that room talking shite and talking shite to each other.
Exactly right. That most surveyors, almost all surveyors, don't think the Earth is flat.
It's irrelevant. Maybe they've never had a conversation.
That was what was asked. He was asked if surveyors do that. People who do this every day. Yeah.
No, it's not what I asked.
No, it's not.
No.
You don't even know what he asked, Kosho.
The thing is, a lot of this is very academic, and it's removed from reality. This stuff is written
academic.
From
it's not. It's practical.
To be honest,
surveying is practical. It's not academic at all.
It's just theory. It's just a bunch of theoretical nonsense.
It's not. It is a practical application that people do in reality every day. It's not theoretical.
What are you saying?
The part where they add globe curvature.
Who?
It's a theoretical assumption.
Who? The ballers?
Books where they have charts of curvature, even for surveying, that doesn't really relate to reality. So there's an academic.
So why are you talking about it?
Practice.
Why are you talking about it?
More. We didn't know what you was talking about. Try and.
Well, earlier in the show, we had this dude, whatever the hell his name is, bringing up the
that guy. Yeah, that guy. I know him.
Yeah.
It was another dude. But anyway, he brought in a textbook that supposedly, quote unquote, referred to, aircraft pilots having to account for the curvature, but it's on an academic level. On a practical level, people don't account for it. So there appears to be a big disconnect here between the theory and the practice.
But we're just talking about the practice to people that are just making stuff up.
Yeah, and it's the same for surveyors. I'm sure Rodney would tell the same story.
I mean, most surveyors that I've talked to, I've never talked to one that was a flat earther to begin with, but I'll just say they connect the dots pretty quick once you start asking some questions and pointing out obvious things.
Yeah, if they've never had that conversation, Rodney, exactly, they may just have never thought about it.
They don't.
That's been my experience.
In the same boat, was we not, at one point?
And most people are on some level mindless paper pushers. They do their job and they go home. They don't think about the implications of saying, I'm a surveyor. Do I really use 8 inches per mile squared, or do I use a fudge factor, a general fudge factor?
Lemon, stop it. Lemon, stop it. Stop it. Surveyors do not use 8 inches. They don't even know about it. It's only people in rooms like this that talk about it. Like, if you've noticed, Rodney won't talk about it. I won't talk about it. Nobody else talks about it. It's only people that are obsessed with trying to express a curvature with a number. And it's that number that you keep spurting out. Nobody ever uses it in reality, in real life, every day. Nobody.
It's made up. Surveyors are actually trained not to think about all that.
Mm-hmm. So just please stop using it. There's no need. All you're doing is adding to people's fantasy. Of an unrealistic fantasy as well. Stop doing it.
All fantasies are unrealistic, aren't they? I hope.
There's no point keep talking about a number that's supposed to express a curvature that doesn't. The only way you can express a curvature is by describing the circle that the curvature belongs to. That isn't with a formula like 8 inches times the distance in miles squared. That just doesn't express a curvature. It doesn't work. People even know that. So you know it doesn't express a curvature, but you still use it. It's a fantasy thing. Just give it up.
Why do you think they put it in books then? In booklets and manuals or whatever?
Because they want people to keep talking about it. They want it to go out into the greater world. Then you can keep talking about it, and everybody else will think, oh great, even Lemon's talking about the curvature of the earth. Must be real. The people keep talking about it.
The curvature that is expected to be there but isn't.
Well, exactly. There's no point talking about it.
They're talking about a curvature that shouldn't be there in these manuals or whatever, and we're not in practice really seeing it.
So why keep talking about it?
It would be a way to show that they're basically lying. That
was Robot who came up with that number first, or that equation first.
Demanded by the math. That's demanded by the globe math. It reduces to 8 inches per mile squared curvature for a circle of 24,000-ish miles.
Talk about circles as much as you want. Doesn't make them come true, does it? Does in some people's minds, though. The more you talk about it, the more you reinforce their belief that circle's real. Keep talking about it.
Keep talking about it, Lyndon.
Can we say this has been put to bed?
Lie is a way to destroy the lie. Once you see the lie isn't there, it basically destroys itself. We're not seeing this 8 inches per mile squared, so with that metric,
keep mentioning it.
Cover the false.
Keep repeating it.
Mm-hmm.
You keep repeating the truth. If you can repeat the lie, you can repeat the truth.
Yeah, it's just flat.
We'll do the truth.
So this argument's over then. There's no more debate. We've just got to get it out to the masses now.
That'll never happen, will it?
Yeah,
the main thing is giving them tools so they can figure it out for themselves. Be like, hey, do we see 8 inches per mile squared of curvature that's
Keep saying it.
He just did it again.
Let's go. Let's go, Lemon. Let's do it again.
Stop. As long as you give them a tool for discernment to tell what's flat versus what's curved, they'll be fine.
Keep talking about Father Christmas. I'm sure he'll come.
Right, now what we're going to rip to bits then?
I'm going to go to bed.
I think we need more surveyors, just telling the truth like Rodney is.
Yeah, they'll come of their own accord. Don't put pressure on them. Like I say, but Rodney's said that they like the surveyors are in the best position, but you're dropping something on someone that like some people aren't ready for. So you've got to be careful.
Yeah, so I'm not gonna be able to talk anymore. You're more than welcome to text, but no, the surveyors are not on your side, as evidenced by the surveyors you spoke to on Reddit, Bev.
Which ones were that?
Negator is the master of the hit and run.
Is that the Oh, he said he was going in the thing, right? Yeah. On Reddit, I did go on and talk. I asked some surveyors the question about level being horizontal, and guess what? It appears that all of the trolls have got trolls all over Reddit and everywhere. So I got all of my posts downvoted and all of that. So yeah, well done, trolls. Very well done. Like, all just for asking about level being horizontal in a water test. It appears people get really freaked out over really simple things.
I've asked a few surveyors that question, and they all said level is horizontal.
Mm-hmm. Yeah. The ones on I don't think they're really surveyors on Reddit.
Don't like to give you distance on local.
See, look, Mark Taylor's in the chat there. Look, Bev ain't realised we run this. What he means is all the little trolls, the people that don't actually know anything, that are just willing to come in here and argue and not help and just obfuscate and run you all around the corners. Stand there right in front of people like Rodney and tell Rodney that they've read a book about surveying, that Rodney doesn't know what he's doing. Mark Taylor, all the people. McToon's willing to call the police on me for sharing a video. Jose blocking us from his Discord because he said that he slanders everyone. There's a great group of people around here.
The internet surveyors are irrelevant now.
Can you guys hear me?
Yeah.
I'm here. Bev?
Yeah, man.
I think you're great. You're too smart for these fucking guys. And they hate it. They know you don't let them
hit the keyboard
divert.
now.
Yeah, fuck. Thanks for being here, Bev. I really appreciate it. Just wanted you to know that.
Cheers, Rob. I'm off. Catch you all later.
Yeah, me, Bev. Night, mate.
Hey, guys, have a great night.